I'm quite excited to hear all my fellow panelists here, the presentations which have been made. I think that's something which we all imbibe in the kind of work we are all doing, and that's really the future which requires us to consciously think about things. And in my presentation, I think the topic that's been kept is decarbonizing the built environment and how embodied carbon and life cycle models are playing their role. That's what I'll cover. Um, Before I begin, I think we keep hearing about a lot of terms in this field of sustainability, and decarbonization is one such term which is quite extensively used, heard, read at different places and forums and the articles. It's important that as a community, what does it mean really, and the theoretical meaning of that, and how can we really use that in our projects is very important. So if you really go by what the word decarbonization means, it's a process of reducing CO2 emissions that contribute to global warming and climate change. So we see a lot of these problems we've heard in the previous talks by the speakers also, the kind of problems that we are facing because of carbon emissions. And how do we remove is what the decarbonization is all about. When we talk of decarbonization, it involves shifting from fossil fuel usage to renewable energy sources. It requires improving energy efficiency at first. So we heard about passive design, active design. All of those measures are really important to first of all reduce the consumption of our energy, which ultimately is the result to carbon as well. And then making sure that what we consume is more clean, adopting sustainability practices in every aspect of our lives. So, of course, we belong to the building, but buildings are one mean of carbon emissions, but carbon emissions happen in our various aspects of our lives also, which is what we have to really see. Now, we may say, why do we talk about it and why carbon matters a lot? Because these are some of the areas where carbon dioxide emissions are impacting us directly or indirectly. So these are all the impacts of carbon emissions that we see. They're definitely contributing to the global warming and the trapping of heat in the atmosphere, which ultimately is responsible for global warming and GHG emissions. We keep hearing about natural calamities here and there. Those are somewhere related to all of these issues. High carbon levels also harm the ecosystems which we have, not just the human lives, but the uh, uh, lives of all the living beings. Biodiversity is being impacted, food security. So a lot of these issues are there. Now, when we look at the types of carbon, especially in a building context, there are two sets of areas to look at. One is the embodied carbon and the other is operational carbon. Together, they make whole life carbon. That's the overall concept that is required to be addressed properly. Embodied carbon, what you see on the left-hand side is basically to do with a lot of the material selection and the usage that we have in the process of building construction, while the operational carbon is more to do with how much emissions are there in the operational part of the building. Embodied is related to the materials, manufacturing, transportation, and installation of all the materials. And this is more related to the amount of consumption we have of the energy in the building. When you look at embodied carbon, which is one key area which a lot of focus, because for any building, and it's important to understand that between embodied and operational carbon, we still have a leeway to manage operational carbon during the entire operational phase of the building. But what we build today, it's going to last for next 40, 50 years for any building. So embodied carbon, if we, whatever we consume today is going to last for the rest of the life of the building. So it is very important to deal with embodied carbon at first, and then of course look at operational carbon also. Fortunately or unfortunately, there is a lot of work which is yet to happen in the embodied carbon area. There are a lot of materials which are present, but uh, they may or may not be adequate enough to address all the building requirements, for all the types of buildings. So accordingly, we have to see and we can choose the kind of different materials which can be suitable to our requirements in the type of buildings that we use, and accordingly we can see what benefit can we bring in to the embodied carbon reduction. There's a concept of LCA. I think this has been touched in some of the previous talks also. LCA is basically a systematic process of analyzing what the impact on the environment of any production cycle of the product or the building is going to be there. So that's what the life cycle assessment is. There are different frameworks available how to for the LCA itself. So ISO standards are available which define the methodology and the protocol of how the LCA should be conducted. What it requires overall impact categories of life cycle assessment. This is what is shown here. So there are 6 main impact categories where the LCAs are focused, and embodied carbon is also assessed for climate change adaptation, protection and restoration of biodiversity and ecosystem, pollution prevention control, transition to a circular economy, protection of water and marine resources, and the climate change mitigation. These are 6 main areas. And life cycle assessments can be done at 2 different levels. One is for the entire building, so whole building life cycle assessment, and the other one is for the product life cycle assessment. So product, we use a lot of products in a building, and at every product level also the LCA can be done to identify what has gone in the manufacturing of that particular product. Together, when the set of products make the building, that's where the whole building life cycle assessment is also done, and to assess how the environmental impact of a building and its products going to be. There are different models available to do that. So for example, you can see cradle to gate, cradle to grave, and cradle to cradle. These are 3 different types of assessments which are done for life cycle models. And cradle to grave, just to give an idea, refers to the assessment of a partial product life cycle from the extraction to the manufacturing facilities gate. So whatever happens before the product goes out, that is what is measured in the cradle to gate. Cradle to grave is till the start to the end of the particular product's life, and cradle to cradle is the entire loop of the product being taken into the cycle of manufacturing, the end of life, and the refurbishment of that. These are different stages. We touched upon it in the previous presentation. I'll not go into details, but this is how it is breaken up. A1 to A3 is a product stage, A4 to A5 is a construction stage, B1 to B5 is a use stage, and C1 to C4 is an end of life stage. So different stages, we can do the analysis to see what impact is being made in at what stage. These are when we do the assessment for embodied carbon of a building, these are the areas that we identify. What is the global warming potential? What is the eutrophication potential, acidification, ozone depletion, non-renewable energy sources, and biogenic carbon. As I say, there is a product-based LCA also available that is basically to map the overall inventory and the carbon emissions the manufacturing of a product. And as a byproduct and as a result of LCA exercise, the impact categories that you have analyzed, there's something called environment product declaration. It is nothing but a document which tells you that in the manufacturing process of a product, what is the kind of impact has been made, in the particular product. So simple item that we can keep a check if we really want to assess the embodied carbon of a product or a building also. Choose the materials which have got EPDs available for them. So that will help you analyze the carbon footprint and the embodied carbon of the building in a much more easier and a simplified and much more verifiable way also. And of course, there are different certifications which are available for the buildings. Like we spoke about IGBC, LEED, CREA, Edge, International Living Future Institute. They all do their own assessment. They have their own rating programs developed uh, to see how the best framework can be applied to the building. Of course, it belongs to team how they take it, how consciously they take it. But what we have seen is the direction which green building rating systems have given to the industry is much more streamlined process. So from the architecture to construction, so there is a set structure which can be followed. How much do we follow? What do we do is something that is depend on the project type and the team's capabilities. But this is the frameworks available. Overall, today we stand on number three in the world as far as the green footprint is concerned, which is good, but not enough. We have to do a lot more because the construction, which is yet to happen in our country, is humongous, and there's a lot more which can be done. Particularly coming to the materials which have a high carbon potential, and this is how the pie chart that you see different materials, the contribution they make in the carbon emissions is what is mapped here. And there are some big ticket items, especially like materials like concrete, steel, clay bricks, plaster. They are the big ticket items. If we are able to control these in a building, our in much better control. These are some of the percentages that you see in different material. How much the CO2 emissions can be identified. I'm not going into details because the time is short. Concrete is one biggest item to be looked at. How sustainable is that? Fly ash is one good alternate. GGBS is another alternate which can be used in combination to the the kind of concrete we make, and also the blocks that we use for the building. Steel, there's enough alternates available in the low carbon steel options as well. We have to see how best can we use without compromising the building strength and the quality. Wherever is the best area to utilize more recycled steel, more green steel, I think those are options. It is up to us how best do we use that, and there's good amount of reduction that is possible. Traditional method of manufacturing the steel used to be blast furnaces, which is very high intensive in terms of energy and embodied carbon, which is getting shifted to electric arc furnaces in the newer systems. And that's where a lot of reduction in terms of the emissions are able to be there. Aluminum production is another big area of carbon emissions. These are some of the areas where we use aluminum, and the recycled aluminum content, which we can really look at. Glass is another one, approximately 1.5% of global CO2 emissions. So we have to consciously use it. Timber and wood is not too much used in Indian construction, but it does have fair share of use in the other parts of the world. It also have got around 0.5% of global CO2 emissions. Instead of red bricks, of course, there are good alternates to fly ash and AAC blocks, which can be used where the carbon emissions can be reduced. And these are some of the alternates of the cement where global warming potential, if you see, significantly drops down as you choose different alternates over there from 995 to 325. There is a potential rise between these products. Fly ash, GGBS, the replacement material, how much can you replace in your concrete? How much GWP will it really help? This is the number. So the higher the content of these alternate materials to your RMCs, better is your carbon footprint for that particular product. Steel burning furnaces, electric furnaces, you can see the amount of difference that it can make in the
Sir,
overall CO2 emissions.
excuse me.
Yeah, I'm
Ashish,
finishing it.
no problem.
Yeah.
So just in the interest of time.
Yeah, just last two slides. This is a case study for one of the projects with the mixing of GGBS recycled steel. How much reduction can it really make in different scenarios? Those and there is a 25% reduction in the overall CO2 emission that can be done. So overall, if you see key stakeholders, there are everyone is responsible when it comes to the whole life carbon performance. Everyone has a contribution to make, and that's where it's important that we holistically address the carbon emission problem. And this is where I would like to end. Thank you.